Hi, everyone. So, when we think of AI, we imagine chatbots or image generators, right? But there is another kind of AI that's quietly changing science since the beginning of this year. And I want to one that can actually look at ordinary tables and time and figure out how things actually cause each other. So, this is TabPFN. It's made by the team at Prior Labs, and it's an open source transformer that understands real world data. So no words, no pixels, just spreadsheets. And I want to quickly go through their example they have in Colab so you can better understand how the project works. So the first thing they do, the dataset table. So here is how it starts. It loads the dataset, and okay, I think it's yeah. Each row here is a monthly record, right? And you'll notice that all these columns with sin and cost values. So that's how the model encodes time. So it uses waves instead of numbers. So it knows December and January are neighbors, not far apart. And this helps the AI feel the cycles like seasons or business patterns the same way we sense repetition over time. And here in the graph above, they have this time series plot. So the blue line is the real data, like I don't know sales or energy usage, and the red dashes line marks the point where the model stops learning and starts predicting. So the repeating waves show clear yearly patterns, and the model's job is to keep that rhythm going into the future. We also have the causal graph, which okay, which is down here. So it's this simple triangle that shows how TabPFN handles cause and effect. So X here is the background information, T is the action we take, like giving, I don't know, a discount or treatment, and Y is the result. So this arrow means they influence each other. And this, the AI can learns to see how changing the action changes the outcome instead of just spotting coincidence. Then, okay, we run these scatter plots that basically shows um, every dot like is one example, where the blue points are one version of the action and the red points are another. And on the x-axis we have the features, and on the y-axis we have the effect. So you can see how the two groups separate. That's the model learning the difference an action makes. So in other words, what happens if you do something versus if you don't. Then they go into the model comparison. So here for that we use the CATA estimation, and these three panels actually compare the models themselves. So the first one is TabPFN, the one they use, and we can see how it stays tight around the diagonal line, which means it predicts much closer to reality than the older models on the right, like CFD-ML and Default and TabPFN. So these are just a few graphs, and we saw that AI can read time, understand causes. I want to keep this video short, but I still want to tell you a bit about CATE and how it works. So the way they use CATA is uh, is mostly for it's where the causes lead to effects, right? So it how it learns to estimate how big the effect is. And as we have seen the directed edges, basically how the relationship between these three. So this is the causal skeleton of our synthetic data set. X background info, T is the action we take, and Y the result, right? And because X affects both T and Y, it's the non-confounder. So the data set is generated on that, and once we include X, we can fairly measure how changing T really changes Y. So that's what TabPFN is learning. It's not just patterns, that's why it's a cause and effect. So yeah, in just a few graphs, we just saw that AI can also read time, understand causes, and make sense of patterns without giant GPUs and or endless training. So this is a reminder that AI isn't only about language, but it's about understanding the world's data. So if you want to try it yourself, the full notebook is free on the TabPFN GitHub page. I will share the link myself too. And yeah, this is pretty much it. Thanks for watching.